Today we're going to be looking at special parallelograms. So theorem 6.9 states that each diagonal of a rhombus bisects two angles of the rhombus. So if we have our diagonal of this rhombus, that means it bisects each of our angles. So for instance, if this angle was 60 degrees, we know these would be 30 because it's being bisected. Since it is a parallelogram, opposite angles are congruent. And based on theorem 6.9, that both of our angles have been bisected. So theorem 6.10 states that the diagonals of a rhombus are perpendicular. So if we have our diagonals in our rhombus, perpendicular means they're creating 90-degree angles. So our four angles are 90 degrees. So let's look at example 1. We want to find the measure of the numbered angles. So we know we're working with a rhombus because we have four congruent sides. So we also know that this is 130 degrees. So based on this being a rhombus, we also know it has the properties of a parallelogram, which state that these two opposite angles are congruent, as well as the other two. So this has to be 50 degrees, as well as this is 50 degrees. So we know that angle 2, angle 1, angle 4, and angle 3 are all 25 degrees because they're being bisected by the diagonal. In example 2, the measure of angle 1 equals 4x. The measure of angle 2 is 5y minus 20. And the measure of angle 3 is 2z plus 42. Based on this picture, we're working with a rhombus again. We have four congruent sides. And looking at theorem 6.10 that states that our diagonals are perpendicular to each other, that means that angle 1, 2, and 3 are all 90 degrees. So to find x, we know angle 1 is 4x, but it's also equal to 90. So when we divide both sides by 4, x equals 22.5. So now when we go to find y, the measure of angle 2 is 5y minus 20. We also know that angle 2 equals 90 degrees. So if I add 20 to both sides, 5y equals 110. So then when our last step, when we take 110 and we divide it by 5, y equals 22. So then our last one we have to find is z. So angle 3 equals 2z plus 42. And once again, we know that angle 3 also equals 90 degrees. So our first step is we're going to subtract 42 to both sides. So 2z equals 48. Divide both sides by 2. So z equals 24. Theorem 6.11 states that the diagonals of a rectangle are congruent. So if we have both of our diagonals, sorry about that one. We know we have rectangle A, B, C, D. We then know that diagonal AC is congruent to diagonal BD. So we have rectangle DEFG. We want to find the value of x and the length of each diagonal. So we have the diagonal DF, and that's 2x minus 1. Then we have our other diagonal, which is EG, and that one's x plus 3. So based off of theorem 6.11, we know that our diagonals are congruent in a rectangle. So we know that x plus 3 equals 2x minus 1. So I can subtract x. 3 equals x minus 1. Add 1. 4 equals x. So now that we know what x, we can find the length of each diagonal. So the length of DF we know is 2x minus 1. But we just found out that x equals 4, so 2 times 4 is 8. And 8 minus 1 is 7, so we know the length of DF is 7. So that means that the length of our diagonal EG should also equal 7. So if we plug in our 4 just to make sure we did it correctly, we know EG does, in fact, equal 7. Alright, so theorem 6.12 states that if one diagonal of a parallelogram bisects two angles of a parallelogram, then the parallelogram is a rhombus. So here we're looking at our diagonal that bisects two angles. Theorem 6.13, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So diagonals, and they're perpendicular. If the diagonals of a parallelogram are congruent, then it is a rectangle. So here the diagonals are congruent. So in example 4, we want to conclude whether the parallelogram is a rhombus or if it's a rectangle. So if we're looking here, we have a diagonal and it's bisecting two angles. So this is a rhombus. So two angles are bisected. And that's theorem 6.9. In this one, we can't conclude that it's a rhombus or a rectangle, so no, we can't conclude because we don't know if the diagonals are congruent, which would make it a rectangle, or if they are perpendicular, which would make it a rhombus. So looking at this last picture, we're given this parallelogram and we have two diagonals, and it's telling us that diagonal AC is congruent to diagonal BD. So this is a rectangle because the diagonals are congruent. And that's based off of theorem 6.11.